Right. Hi, everyone. Welcome to today's webinar where we'll be exploring Flexware Innovation's intralogistics platform Lift. My name is Ellie Allen Bathe, and I'm a content marketing manager here at Flexware. I'm joined today by three of our Lift experts who I will introduce shortly. But before I do that, a couple quick housekeeping notes. First, if you have any questions throughout today's webinar, feel free to drop them in the questions tab of your toolbar, and we'll answer those at the end. Secondly, we are recording, so I'll make that link available to you shortly after we wrap up. And finally, we're scheduled for an hour today, but if we wrap up early, we'll give you some time back into your day. Now that we've got that out of the way, I'll introduce today's speakers. I'm joined today by Bryce Bucher, Jacob Clodfelter, and Will Nichols. All three of our experts are focused on helping manufacturers effectively automate material movement. Bryce is the Vice President of Products and has helped shape product strategy at Flexware for the past 14 years. Jacob is a solutions architect with nearly a decade of experience supporting the manufacturing industry. He has been at Flexware for a little over a year and a half. And finally, we have Will, who is a senior products engineer and has spent more than 8 years at Flexware providing technical expertise in data analytics and machine learning. He leads our tip of the spear research efforts. Team, take it away.
All right, thanks, Ellie. So this is Bryce speaking. So as Ellie mentioned, I'm the head of product here at Flexware. And the three of us are going to be tag teaming this webinar today. We have a lot of content to get through. But let me start by just running through the agenda at a very high level. So I'm going to spend a few minutes just talking about Flexware as a company and also the problem space that Lift has been designed in order to be able to address. I'm going to hand it over to Will at that point, who's going to give us a brief overview of Lift from a product standpoint. And then Jacob will take over for the meat of the presentation, where he will be doing a live demo showing everyone Lift in action. We'll come back to Will after that, and Will will talk a little bit about roadmap items, things that we have under development from a Lift next step standpoint. And then as time allows, we'll hit some Q&A at the end. All right. So let's start real quickly with Flexware Innovation. For those of you that are not aware, we're a software systems integrator. We primarily deliver custom software and systems integration solutions, mostly in the industrial sector, primarily for manufacturers and for warehousing customers. So we've been in business for almost 30 years now, and we've got just over 200 employees. A large percentage of those are engineers that are actively working on delivering products and solutions for our customers. We were acquired by Hitachi back in 2022, so we're being integrated into that ecosystem and working alongside other Hitachi Group companies as well. So you can see in the middle there some of the verticals that we play in. Pretty much anything in the manufacturing sector is fair game for us, and we have some fairly deep domain knowledge when it comes to those industries. And then as far as our competencies go there on the right, so we do everything we say from the shop floor all the way to the top floor. We do controls and automation, as well as integration and software development, and then higher level business intelligence. And we also have a few products in our portfolio as well. So let's talk just real quickly about our different array of offerings. So a lot of what we do here at Flexware is custom services. This is work for hire that we do for customers based on individual project requirements in those various spaces that I mentioned earlier. But occasionally we will start to build up what we call solutions there in the middle, which are typically toolkits or accelerators, mostly built on top of other platforms like Ignition. And the whole goal here is to be able to accelerate projects and to be able to get things done faster at a lower cost. So you see a couple of our solutions there in the middle, part of our Spark platform that's built on top of Ignition. And then finally, we've evolved some of our solutions into full mature products. On the right there, we have a product called Acuments, which is a manufacturing intelligence product, and as well as our Lift platform, which we're going to be talking about today. So let's go into Lift, and specifically, let's start with the problem space that Lift has been designed in order to be able to address. And we call Lift an intralogistics platform. So it addresses intralogistics areas And when we talk about intralogistics, we're talking about the movement of materials and items inside of the four walls of a facility. So we're not addressing things on the broader supply chain or logistics items outside of the facility, but once you have to start moving items around your facility, that's what we're talking about when we talk about intralogistics, and that is the problem space that we're trying to address here. We typically use this model when we communicate to customers kind of the complexity of this. Anyone that's worked in intralogistics probably gets this, but we use this kind of what, where, and how model to define this. So when we talk about what, we're talking about the types of materials that are being moved around. They come in many shapes and sizes. Sometimes the raw materials coming into your receiving area get transformed into subassemblies and components that get consumed later on in your process. So you're changing size, you're changing shape as you go through the process, and that leads to some complexity. The second piece of there, the where, is the different locations where these items have to be picked from and dropped to. Everything from high bay storage or narrow aisle storage racks in your warehousing areas to floor locations out on your shop floor, to in-feed conveyors, robot cells, you name it, different equipment that you may need to pass materials to and from throughout your process. And then the last part there, the how, um, many different systems and machines are involved in order to be able to move all of these materials around. You've got a mixture of both automated systems, as well as a lot of these things are still being done by hand by humans as well. So that leads to some complexity as well. The thing we like to highlight here is at the bottom of the page, the continuous decision logic and exception handling. So if we are talking about now introducing automation into intralogistics, whether it be through autonomous mobile robots or ASRS systems or WMS systems or conveyors, you name it, any piece of automation, you're going to want to be able to keep the system up and moving, and you want to automate the process end to end as much as you possibly can. And keeping in mind the fact that you are largely now automating processes that were done previously manually by humans, you want to be able to meet or exceed the level of decision making of the systems that you're replacing. So think about, when you arrive at a location, you're supposed to be dropping at a particular spot, but let's say that spot is occupied. You want to be able to quickly make a decision about, well, where do I put it now? What do I do with it? You don't want the system just to stop moving because now you've got all this investment in automation, but the automation is down. So we talk a lot about the concept of business logic and decision handling, and that's one of the big value points that we're trying to hit with Lyft. So let's get into what Lyft is. So Lyft is software. It is what we call a system agnostic intralogistics platform, and it's designed to be able to, connect systems and processes together and to be able to help drive some ROI on projects. It's been designed specifically for manufacturing and warehousing organizations. And our key business goal is to help those customers increase the ROI that they experience when it comes to automation inside of intralogistics. And that's very simply through two different avenues. The first of those is reducing the capital cost. So the original capital expenditure, these tend to happen through capital programs. We want to make sure that those projects get implemented as quickly as possible with as few of services as possible and driving down that cost and improving the timeline as much as possible. So some of our market research indicates that the software integration piece of these projects tends to be 25 to 35% of the overall project cost. So if we can get that down significantly, and we're aiming to get that down lower than 15% of the cost, then there's significant savings that can be achieved on the front end of these projects. And the second thing is we want to reduce the ongoing cost to maintain these solutions as well. And that really comes in a couple different ways. One, we want to be able to reduce downtime. So the situation we talked about earlier where you arrive at a position, you're supposed to be dropping at that position, but that position is occupied. You want to be able to quickly make a good decision on where you want that thing to go next so that that robot can keep moving and moving on to its next mission. If we can reduce the amount of downtime that's happening with our automated solution, then we're going to increase one of the key metrics that's used, which is mean time between failure. And the other thing is, if downtime does occur, we want to be able to alert the proper technicians as quickly as possible. We want to provide them with as much information as they need to be able to drive to root cause analysis and get that thing back up and running as quickly as possible. So if we can reduce that amount of downtime we have, then we're helping to decrease that mean time to repair metric, which is so key in some of the optimization that comes with ongoing maintenance. So keeping those two value points in mind, let's talk about a couple of terms that we're going to be using as we start to describe the problems that Lyft solves. So what we're looking at here is a very simple model that we like to use to be able to establish a conversation with customers as they're embarking on their digital transformation journey. They're starting to introduce automation into intralogistics. This model kind of represents how that journey tends to play out for a typical customer. So on the horizontal axis there, we see the customer intralogistics maturity level. You can kind of think about this as a timeline from left to right, and as you go through time, you're going to become more mature as you start to introduce more automation into your processes. The vertical axis is the effort or challenge that you're going to face as you're going through that journey. So what we typically see is that early on, as customers start to automate intralogistics, the first challenge that we see them facing is what we call orchestration. That's the blue curve here. And orchestration we like to refer to as just strategic coordination between all of the system components, the robots, the software, the people, etc. And this encompasses that business logic and decision making that I was talking about earlier. Again, we're trying to automate these processes end to end. There's some complexity there. You need lots of data in order to be able to make the right decision at the right time in the right moment. So we call all of that orchestration, and that is a main value proposition for Lyft and the problem that we're hoping to solve first for customers. As you go left to right in your maturity curve and you start to introduce more automation, you're going to start to get a handle on that orchestration. It's going to become less of a problem. But what we do see is the presence of another problem called interoperability. And when we talk about interoperability, we like to use the phrase effective cooperation. And in this case, we're talking about cooperation between different robot systems that you have implemented in order to be able to operate effectively in the same physical environment. So let's take a very classic use case. Let's say that you already have a fleet of AGVs that's moving materials from your warehouse to staging areas by your line. So that was project number one. And then project number two, you're going to come behind that later and you want to handle the last mile there where you have a fleet of AMRs. They're going to pick the materials up from the staging locations and then take them into the nooks and crannies of the equipment itself, navigating tight spaces in some cases to be able to drop those materials at the point of use locations. You couple those two things together between your AGVs and your AMRs, and now you've got two different fleets of vehicles that are now operating in the same physical space, in some cases using the same aisleways and intersections, in other cases using the same drop and pick locations. And you have to make sure that they are doing that safely and effectively between the two. The problems that we tend to see when you have these mixed or cross fleets is that they are sometimes provided by different vendors because of the vehicle style that's required. And in some cases, they have different fleet managers on top of them. So even though each fleet knows exactly where its fleet of vehicles is and can do the right traffic management and route planning for those vehicles, they don't know about the other fleet. And so what we see is these two mixed fleets get close to one another and end up violating one another's safety sensors. And at that point in time, you are in what we call a deadlock situation. So one of those vehicles or both of them is deadlocked and down, and there's no choice but to manually intervene in order to get those back up and running. That can be very costly. We want to avoid that if possible. So that interoperability problem is definitely a problem that you're going to see later on in your journey, and we want to address that as well. So I'm going to wrap up here just with the value proposition of Lyft. So as I mentioned earlier, we're going to start by addressing the orchestration problem. We do that through this tagline we call integrate, simplify, and optimize. The integrate part of that's pretty self-explanatory. We want to be able to seamlessly connect all of your systems together. And we want to be able to integrate between all of your various system components. The second one of those, simplify. This is where we want to be able to, through a modern user experience and great software, be able to put the configuration and the power into the hands of the users. And we want them to be able to configure some of this advanced level business logic we talked about earlier without having to know how to program or write code. We want them to be able to do that just through interacting with the software itself. And then finally, the optimized component there is all of the things that are involved with reducing the ongoing maintenance cost for this, keeping the system up and running, making sure that we can scale the system out, roll it out to additional pieces of equipment, additional sites, et cetera, and do that as quickly and effectively as possible. We pull all that stuff together. It's what we call comprehensive orchestration. And as we mentioned earlier, we're also going to be addressing the problem of interoperability you see there on the right. And we're going to do that through a couple of add-ons that we'll talk a little bit more about later in this call. But the whole point there is, again, being able to have effective cooperation between different fleets of vehicles that are performing different tasks, but are doing so in the same physical space. So if you combine all that stuff together, it's what we call unified intralogistics. So it's our goal to kind of pull everything together through Lift to be able to create this holistic intralogistics system that's very sophisticated, very easy to use, very easy to scale. The last point I want to hit on is there's another term you're going to hear a lot as you start to get into intralogistics, and that is the concept of a fleet manager. And there's a lot of overlap between various software platforms that are out there. And in some cases, people think that some of the things we're talking about here can be done through a fleet manager. And the answer is, in some cases, yes, some of the stuff can be done. But we are purposely not putting fleet management capabilities into Lyft. We are concentrating on the orchestration and the interoperability problem, as we mentioned earlier. And what we want to do is be able to meet fleet managers where they are at through their APIs. So Fleet Manager, very simply, these are softwares that typically are coupled with fleets of robots or vehicles that handle all the route planning and traffic management for that fleet. They do a very good job of that and typically can interface with the outside world through their APIs. So Lyft would plug into their API, be able to dispatch missions to them, be able to monitor status from them, report status back into the larger system. But again, not getting into the concept of fleet management. So hopefully that's a clear enough term for everybody, and we'll refer back to that as we go forward here. So next, I'm going to turn over to Will for an overview of Lyft as a product.
All righty. Thank you very much, Bryce. Like Bryce said, my name is Will Nichols, and I'm going to talk a little bit about Lyft, the product. So Bryce did a really great job of setting up why you might need Lyft in your facility. Let's talk a little bit about what Lyft is, how Lyft operates. So Lyft exists to connect all of your systems and processes together in order to enable that unified intralogistics that Bryce was talking about. As you can see here, Lyft kind of sits in the middle of all of these different systems. And so rather than having each system talk to each other in a complex tangled web, Lyft is able to kind of cut through that Gordian knot and have it be the central place. That offers a few key benefits here. Primarily is it removes all of that business logic and decision making into a single spot. And that really enables that customer ownership that we were talking about by having everything there in that single space to be able to simplify all of those decisions that have to be made. As you can see here, Lyft can interact with all sorts of different types of systems across your manufacturing or warehousing facility, all the way from your high-level systems like your ERP, WMS, or MES systems. Obviously, we connect with the various fleet managers that we have to connect with, but we can also go as low as communicating directly with ASRSs, doors, robots, elevators, conveyors, as well as individual PLCs and vehicle controls over our OPC UA integrations. So we bring all of these different systems together, and that's what enables one of the core features of Lyft, which is this centralized multi-agent orchestration. It's seamlessly connecting all of these systems together through our robust integration framework. And we support a number of different protocols here. We support OPC UA, MQTT, as well as directly interacting with the various APIs for these various systems as well. We bring all of those integrations together into our flow-based configuration editor, which Jacob will show us here momentarily, which is an intuitive drag and drop flowchart editor for creating and managing these business workflows and being able to encapsulate all of that decision making in a clear visual representation. Something I like to call out on our flow-based editor is that it is a interactive process diagram that's self-documenting. You can clearly see what's going on. Those are the kind of the core features of Lyft, and we've also got a couple other features that we think elevates Lyft into that enterprise-grade intralogistics solution. We've got advanced user management through role-based access controls, single sign-on support, and multi-factor authentication. A comprehensive alerting system to enable those to make sure that people are notified at the right time for the right reasons. We've got a global accessibility through a modern, modern responsive UI that supports multilingual support, dark mode, and responsive design. And one of the because Lyft is targeted at manufacturing and warehouse operations, we wanted to build Lyft is built from the ground up to support air-gapped installations. So Lyft entirely can be entirely installed on an air-gapped OT network with no internet connectivity required. Also have a suite of online and offline documentation available within the app so that technicians are able to diagnose and understand issues without having to connect to the internet. So architecture, so we've talked a little bit about what Lyft is and the core feature set. Let's talk a little bit about the Lyft architecture. As I said, Lyft will typically exist on a VM on your OT network. That VM is going to host the Lyft web interface, and it's going to communicate with these various integrations and add-ons through an event bus. So an integration is simply an interface between Lyft and an external system. It supplies that translation layer that simplifies interacting with those external systems. We have off-the-shelf available market integrations, as well as the ability to quickly spin up any custom integration work that might be required. Additionally, we have add-ons, which we'll talk more about later, but in a nutshell, add-ons are software expanders that add new features and capabilities to Lyft. And now that we understand, Bryce has talked about why you might need Lyft. I've talked about what Lyft is and how it's architected. I'm going to turn it over to Jacob here for our demonstration. He's going to run you through the UI. Jacob?
Thanks, Will. Be happy to start the demo here in just a moment. And we're going to be giving you an inside look at the Lyft platform in detail and walk you through every feature or many of the features that were discussed by Bryce and Will previously. So what you see here is we're inside the flow designer, and a flow is the basic building block for logic inside of Lyft. A flow is a set of ordered tasks that defines a process. That process is likely to be any number of those business logic cases that Bryce and Will were describing earlier. You have three components to a flow that are a given. You've got a start of the flow. You've got a set of tasks after the start of the flow, and you have a complete of the flow. So let me show you the task layer here, because this is where the meat and potatoes of the logic occurs. So we've got core tasks, we've got location tasks, and we've also got integration specific tasks. So let me call out some of the core tasks here. You can notice that each task will have 4 handles: an inbound to the task, an outbound to the task, a fault or exception to the task, and a potential retry for that task. We've also got conditionals for switch casing between two different paths. And one of our most powerful features here is comprehensive logging and alerting, which Will mentioned earlier. So we also have location specific tasks, which I'll get into in one moment. But Will mentioned the concept of integrations. And an integration is simply an interface between Lyft and any external system. So those external systems are comprised of many of the things that were shown in the orchestration slides of Bryce. And it could be a very diverse landscape. So here you see connections, simulated connections to ERP. You see connections to Fleet Manager Mir, the Mir AMR brand. You see connection integrations to Auto, the AMR brand. And this WLED is an integration to a REST endpoint. We also have integrations to OPC UA. And as Will mentioned, you can also get custom integrations for any external system that you may have in your manufacturing plant that you need to orchestrate. So what you'll notice here is that an integration also provides tasks. So if I see the tasks associated with this integration, the AMR platform Mir, this is an integration to the Mir Fleet Manager and allows me to move AGVs or AMRs, allows me to drop AMRs, and would also allow me to schedule missions. So something that might logically follow here is, where am I dropping these things? Where am I scheduling the mission? And Lyft has an extremely comprehensive location model. So locations are very straightforward. Locations are simply a representation of a physical position in your manufacturing facility. And we've got a number of tasks that allow for very complex movement and orchestration amongst and across fleet management and disparate fleet management platforms across various AMR AGV vendors. One of the most powerful tasks that we have related to locations is that of location search. A location search allows you to filter on various locations. It also allows you to filter by grouped locations. So you can group locations together. Those filters can be assigned to is occupied or is not occupied, type, and whether it is assigned. And moreover, we've got a completely custom attribute field that can be filtered on as well. So let me pull you into the locations a little bit closer here to show you how that works. Locations can be created and nested in any hierarchical organizational pattern that you so desire. And you can also see that locations can be shared across various integrations. So you see a staging location, which is a grouping of locations to stage product, as Bryce referred to earlier, being a very common use case for AGV AMR deployments. And you can see that staging one has shared integrations across REST API, Mir, Auto, and you can have as many different shared integrations as you desire here. What I am also showing you here is that I can add attributes. So I can filter on what color of product, what the order date of that product, what the SKU of that product is when I am trying to determine movement within a flow. So one final note about locations is it may also follow, if you are familiar with AGV AMR fleet managers, that they also have locations inside the fleet manager. And that is exactly how we are mapping locations from that fleet manager into Lyft specific locations. So this is how various fleet managers across many different AGV AMR platforms may share locations amongst themselves. All right, so I am not going to just keep you inside this platform. I think it'd be kind of fun to show you actually moving vehicles. That's what people want to see here. So what we're going to show you is some of those integrations. We've got some of those concepts rather. I've got a staging group location here, and I've got a initial location. And what I'm going to do is I'm going to simulate a ERP order here. So I am going to simulate a SKU being set up for a pick to a staging location and final drop off as well. So what you're going to see here is that I may simulate connection here from many different diversity of platforms. So it could be SAP. We've got support for connections to MES. We've got support for connections to OPC. And any of these can be used as a trigger for movements here. So I'm going to confirm this, and I'm going to show you very quick here an incredibly powerful component of Lyft is not only can I edit flows, I can see them running in real time. So this is the flow that I had just kicked off. And if I go back to the camera here, you're going to see that this auto vehicle is going to retrieve the virtual package represented by the red LED. And once it gets aligned here, it is going to retrieve that virtual item. Of course, it's being very careful. Safety first. And right now, all right, yep, it has retrieved the virtual package. And once again here, I can see this flow being executed in real time, where right now it is searching for an unoccupied location in the staging buffer. So of course, none of those locations are full or occupied. So it's going to pick that very first one here. And what you're going to see in just a moment is a completely different AGV AMR brand, the mirror vehicle going to retrieve that virtual item in the staging location. So here we go. The mirror has gotten its command and is waking up and is going to location to retrieve that item. And once again, you can see all of this coordination between these AGV AMR platforms inside of Lyft in real time. So now we're on to the final lap here. We're taking that virtual material to the final resting place at the end. And of course, yes, our mirror is going to deliver that virtual item to the final destination. And I see all of these steps in real time. So what I want to show you is even more powerful. So I saw it in real time, and this is the flow that I was seeing. Not only can I see it in real time in the viewer, I can also play it back in real time. So I can see the timing of each of the flow commands. I can see what happened during each of these flow commands. As you notice on the left, the staging location is null, which means that it hasn't selected a staging location to drop. And once it does that location search, all right, now I've got an unoccupied location in staging one. All flows that are executed are historized in this way, and you can play them back in a real-time viewer, as you are seeing here. All right, so we've got very comprehensive location-based logic and replay. So let's go even further. So integrations also allow you to map and create what are known as data points. So data points are simply a variable in the external system. So you might say, well, locations are all well and good, but that seems like it only applies to AGVMR. What about MES or SCADA or ERP or WMS, WCS? Well, guess what? You can map any variable that you so desire inside of those external systems as data points. Moreover, I can then use those data points inside of the flow. If you take a look at triggers here, I can add a trigger for a flow from a data point. So now I can take any arbitrary variable in a external system as provided by integrations and use a data point to trigger that flow. And of course, we've got very comprehensive parameterization if you want to get more complex, as well as trigger settings and many different advanced features within each of these tasks. So coming full circle here, let's say I do a location search, and this might be a really common example, is that I do a location search and it doesn't find a available location. So now I've got a stranded vehicle. So we actually don't necessarily need to have a stranded vehicle here. I can log that it did not find a location. I can alert that it did not find a location. And these alerts can go to SMS, email, and in-app banners as well for comprehensive escalation for critical alarms and alerts. And I can also have a completely different path. So let's say I don't find a location. There is no occupied location. Okay, let's move that vehicle to a exception buffer. Let's move it to an exception area or an overflow. And if it does find that location, then let's do something completely different. In fact, let's move an auto and a mirror at the same time. So you can imagine here that we can get very interesting business logic. And I'll briefly show you here some of the more comprehensive flows that we can get to go on here. So I'm not going to take you through each of these stages, but you can see here how we get a lot of different conditional logic here achieving some relatively complex orchestration, and it's all visible, replayable, and auditable within the Lift platform. And speaking of auditing, I am going to also show you that each flow has comprehensive versioning. So we know that software development lifecycle, dev, UAT, prod is super important. So we have draft version, we have approved versions, we have rollback for versions, we have audit trails for users within the system for flow modification. So if somebody makes a mistake or you're testing a flow, it has to be approved first. And guess what? Even if it's approved, even if it's in prod, well, we made a mistake. Well, then we'll just roll that back very naturally, extremely easily for any flow. Another thing too is that I can cascade flows. So I can have a flow call another flow and get really in-depth functional blocking to sort of organize my flows into parent-child relationships. So that gets into some of the more complicated ideation. But if you're a programmer and you're in low code, no code, and you feel a little bit hemmed in, you're more comfortable in an IDE, I get you. Well, guess what? We also have a script task. So you can have all of the Python that you so desire inside of here. And yes, we support pip imports as well. So power users, do not fear. Low code, no code for when you need it, power use when you want it. So let's circle one final time back around here to security. So cybersecurity, ACL, access control list. How am I handling this? So you see that we have many different role management ability, and I can have a user have a comprehensive exception access policy here inside of role management. And of course, I need not mention this, it is a standard, but yes, of course, we have SSL encryption on all traffic inbound and outbound if that is something that you want to set up. And you may wonder, there's a lot going on here. How will I keep track of that? Well, guess what? Every single instance of Lyft comes with documentation as part of the server. So this is completely air gapped. This is hosted on the Lyft server. I have access to this in a complete down scenario. We've got all sorts of documents on here on how to use the Lyft platform and get the most powerful out of it that you would need. So speaking of that, we seemingly went through everything. We showed you the power user, but guess what? We have even more on the horizon. So Will, I'm going to pass it back to Mr. Will, and he's going to take us into the future of the Lyft product.
All righty. Thank you, Jacob. While I'm talking through this, if anyone has any questions, feel free to start typing them into our question and answer box, and we'll get to them here in a little bit. So thanks again, Jacob, for running through the Lyft software. It's got a lot there. So let's talk a little bit about what's coming up next. So Jacob showed you what's happening now. Let's talk a little bit about what's coming up. So Bryce mentioned earlier these two options here are two add-ons to kind of help you with that interoperability space. So our first add-on we have coming up is called Locksmith. It helps you prevent deadlocks. It is a deadlock avoidance and collision avoidance engine. One thing to note is that we've taken a somewhat unique approach to others in the market. Locksmith is not a global fleet planner. We perform all of this avoidance using predictive modeling of the pathing, as well as only needing pause and resume commands to manage that interoperability. Secondly, we have our live map solution. This is another piece of interoperability. It allows customers to visualize locations of multiple vehicles across multiple systems in a real-time map of their own facility. So a little bit about our roadmap and timing. So right now, we're currently working on our Lyft 3.1 release. It's going to support resource management. So a resource is like a vehicle or a person or a cart or a machine, as well as call station support. We're currently working on our robotics integration, as well as a comprehensive REST API, a first-class REST API integration. And all of that's scheduled to release sometime within Q4 of 2025. Coming up next, we have our Lyft 3.2 release, which will include inventory management part 1, as well as dashboarding. We're also targeting to release our Locksmith add-on, as well as a few market integrations that are yet to be determined. Finally, we have our Lyft 3.3 release coming sometime in Q2 2026 and beyond. So finally, we've talked about what Lyft is, we've talked about what's coming next, and let's talk about how you can get Lyft in your facility. So Lyft is a individually licensed software package. We've got a few different license tiers, and then the integrations, add-ons, and maintenance are all sold separately. So first step is to pick your core license, whether that be our basic, professional, or ultimate license. The differentiation here is typically around how many flows you can execute, as well as how many add-ons and integrations that specific license could support. One thing I want to note here before I move on is that every license here is available on either an annual price or on a perpetual basis as well, to help you control whether you want to shift things more into CapEx versus OpEx. So getting back to step one, once you've selected your core license, next you get to pick your integrations. So the OPC UA license is included out of the box with every license. But you'll also need to purchase your integrations for your various systems you'll need to connect to. Then you'll select any add-ons that you want to purchase as part of your package. And then finally, you'll purchase your maintenance tier. All of these maintenance tiers are just a percentage of your total license price. All four of these come together to constitute your complete lift package. Um, with that, that's the end of our presentation. Thank you all so much for your time and attention. I'm going to turn it over to Ellie now, who's going to manage our question and answer session. Thanks again.
Thanks, Will. Got a couple questions to go through here. The first one is there a preferred or recommended sequence of Flexware products? So looking beyond just Lift, but all looking at Spark MES, Lift, Spark SCADA, Ignition, how does all of that work together?
I'll take this one. So it's going to come down to where each of you are at in your digital transformation journey. A lot of customers tend to start on the manufacturing side, so they'll start with MES systems, things like that, more traditional solutions. So in that case, you would probably start with our Spark platform. What we typically see is that the intralogistics automation tends to lag behind the manufacturing automation. If that's the case, then you'd probably look at Lift later on in your journey. Once you've got the systems in place to manage and schedule your manufacturing process, then you may turn your attention to the material handling side of things. But that could be flipped, just depending on use cases, where the most opportunities are for you, etc. But hopefully, we talked earlier about us having solutions from the shop floor to the top floor. Hopefully, wherever you're at in your journey, we'd be able to meet you there and provide some sort of solution or product that can help you.
Awesome. Thanks, Bryce. Another one here is, from what I understand, the robot integrations handle the execution of tasks triggered by various systems. But in this case, who is responsible for scheduling and task planning? And is there an optimization algorithm involved in deciding which robot executes each task?
I'll start here, and then maybe Will and Jacob can add some context as well. So this is it's a complex question. It's a good question. I mentioned earlier that there's lots of overlaps between various product offerings. So when it comes to the concept of scheduling and optimizing all of your material movements, it could come from multiple places. So some of that might be within your fleet manager, because you're trying just to optimize the route planning and the actual movement of goods from A to B. And fleet managers are very good about doing that because they know the whole facility, they know where their vehicles are, they know how to pick the right vehicle for the job based on location, they know how to route that vehicle in the right manner. But in other cases, you might be trying to optimize the execution of tasks so that you keep your overall process moving. So maybe you have 2 calls in for delivery of 2 different materials to do 2 different pieces of equipment, but you might want one of those to happen before the other because there is some piece of information that makes that more important. And if that doesn't happen, then you could experience some sort of downtime or bottleneck in your process. So that's where a system like Lift can come in, because it has its hooks into all these different systems and all of the data that comes along with those systems through the data points that come in and the tasks that come in from the integrations. It should be able to make the right decision about how to dispatch that mission to the fleet manager. And it may choose to dispatch one of those missions before the other because it knows something that the fleet manager doesn't know, which is all this contextual information around there. So that's one example, but then there could be 1,000 other examples too. Your MES system might have access to advanced scheduling information. Your WMS system might have advanced information because it's keeping track of all the inventory throughout the facility. So this decision logic or this behavior that dictates optimization might come from several different places, but The good thing about Lyft is as an orchestration platform, because it has its hooks into all these systems and can bring the data from those systems in, you should have a lot of data available to you to be able to make some of these decisions inside of Lyft through configuration to be able to help optimize things that otherwise you may not be able to optimize just because systems aren't connected.
Great, thanks, Bryce. Next one here is what systems does Lyft currently integrate with, and how difficult is it to build a new integration?
I can start with this one too, and Will and Jacob, please jump in too. So we saw Mir, we saw auto integrations, we saw the OPC integration during the demo. We have integrations already built for some of the larger available OEMs that are out there from a autonomous mobile robot and AGV standpoint. So in addition to Mir and Auto, we have integrations to Navitec, we have integrations to Blobotic. These are both more agnostic fleet management platforms that can service many different vehicle systems. We're working on a REST integration. So what we tried to do is try to meet the market where it is right now, which is trying to hit some of the bigger hitters out there. But again, what you saw was a very modular framework. So we theoretically can build new integrations very quickly. We have a blueprint for that, so we can get those up and running very quickly. We intend to be very nimble when it comes to customer demand. So if we happen to engage with someone on a project where they're implementing a new vehicle system, assuming that vehicle system has a well-documented and available API, we should be able to build an integration up in 1 to 2 weeks, is what we typically see. Another thing that I will add is that we are working on a software development toolkit for our integration so that down the road, we'd be able to partner with either end customers or system integrators to be able to develop your own integrations as well and plug into Lyft. So again, hoping to kind of accelerate the process of connectivity into all these disparate systems that are out there.
And I'll just add to that. As Bryce mentioned, we do our event bus framework really allows this modular approach, and we are able to get both our market integrations as well as any custom integrations spun up fairly quickly. We're talking 1 to 4 weeks, just because of the patterns and experiences across multiple different vendors. So.
Great, thanks. If we want to deploy this solution on premise, what are the recommended hardware specifications to run it efficiently? And do you already have any information about the requirements for Lyft 2.3, which for the live map add-on, even though it is not fully developed yet?
Yeah, I'll start here, and Will, please jump in. But yeah, we have system specifications. I don't have those up in front of me, but I think it's Windows 2019 or above. We have specs as far as the CPUs, RAM, et cetera goes. All of that is readily available, and we can provide it upon request for sure. But it tends to run fairly lightly, so you don't need a super large machine to be able to do that. Will, you want to talk a little bit about Locksmith and LiveMap, but just from a system specification standpoint?
Sure. So our live map visualization is like to your point, it's not implemented yet, but we are anticipating that the visualization suite for live map is going to be browser based. And we're going to optimize that experience appropriately so that it won't require the client PCs to have a lot of hardware required to visualize that software. Obviously, better systems will render it quicker, but we are planning on having that be fairly robust to support lower end systems.
Great, thanks. Next one is, how does Lyft differentiate from a fleet management software?
I'll take this one. Lyft is different from a fleet management software. So a fleet manager is really good at telling a robot how to get from point A to point B. It does the path planning, movement through the facility. It understands where other vehicles of the same fleet are and can route them appropriately around those. It's got the definitions for position A, position B, and where those are physically located. Lift is different in that Lift is the orchestration layer. So Lift is, why is a robot moving from point A to point B? Lift is looking for those signals from ERP or WMS system and telling the fleet manager, hey, I need a robot to move from point A to point B, or a robot to move from point A to C, or I need specific robot 3 to go from point D to point F. So Lyft kind of sits above the fleet managers and is interacting with their APIs directly to kind of dispatch the vehicles that way. We're not really getting into, Lyft doesn't really get into moving the vehicle through the facility.
Great, thanks, Will. Next one, how long does it typically take to implement Lyft?
Well, projects do vary based on complexity, as you can imagine, but what we typically see is implementation of a proof of concept can be done in 2 to 4 weeks typically. Larger, more complex projects that require multiple integrations to multiple systems and some more comprehensive orchestration may be 3 to 6 months. But what we typically like to say is that the lift portion of this, or the integration portion, will not be the bottleneck for the project. Typically, it's you're waiting on the hardware to arrive, and the lead time for the hardware is typically 6 to 9 months in some cases. So we're well within that, but we see typical projects in that 1 to 3 month time frame.
Great, I think we have time for one more. So for our last one here, does Flexware implement Lyft, or does it just sell the software?
Oh, that's a good question. So as I mentioned earlier in the presentation, we have a full services group. So we have experts on staff. We've been implementing Lyft for the past 6 years. So we are more than happy to provide the services to implement Lyft and to do all the software integration that you need for your intralogistics projects. We are also very happy to partner with either integrators or end customers that want to own this themselves, and just provide the software, the training, the support that goes along with Lyft, to be able to enable those teams to be able to implement it themselves. So we really mean it when we say we want to simplify and optimize these projects. So we're happy just to sell the software and support entities out there that are doing the implementation themselves.
Actually, I think we will have time for one more. So if we answer this one quick, what is the common use case for Lyft?
Well, I think that anytime you have the need to be able to connect multiple systems together in order to be able to fully automate an intralogistics process, it is a classic use case for Lyft. So what we tend to like to say is, let's start with something simple. So let's imagine a material replenishment operation where you're simply taking a material from a warehouse and you're delivering it line side to a piece of equipment. On the surface, that may seem very straightforward. You may look to purchase an automated vehicle that will do that for you, and you think you're kind of done. It seems like a point-to-point move. But when you start peeling back the layers of what do I have to do to fully automate that process and really to drive out all of the manual interaction to reduce my downtime and so forth, you start looking at, well, I need some way to trigger that. So that requires integration either with a piece of equipment or another system, or maybe it's just a basic call station dashboard for an operator to be able to hit a button on at the very least. But you need some other system to be able to do that. You might need to be able to connect to either an MES or a WMS system to pull a piece of inventory information or some additional direction on the task that needs to be provided. And then when you get there, you may have to handshake with a piece of equipment because you don't want to just drop it on the floor if there's a way to be able to feed that directly into a piece of equipment. So again, trying to drive out the manual intervention here. So any sort of handshaking with equipment, of course, is going to be another integration to another piece of another system using some communication protocol and handshaking technique to make sure that you're safely and effectively passing that material over. And then when you're done, you might want to communicate back to an inventory management system like a WMS to say that that move has been completed so that it can do the move transaction on its side and move that inventory. You take a step back and you look at that very simple use case. All of a sudden, you've got 4 or 5 systems you're having to communicate with and a lot of orchestration and coordination between those systems. So we like to say that Lyft can probably add value in any intralogistics automation project, but surely if you're starting to do more advanced things, you're going to need something like Lyft in order to be able to connect everything together.
Awesome. Thanks, Bryce. And thank you all for joining us today. If you have any questions that we weren't able to answer, you can fill them out in the survey that will pop up shortly after you leave today's webinar, or you can reply to the email that I'll be sending out shortly after we wrap up with the recording link, and we can get those questions answered for you. We can also get you set up with a personalized demo if you'd like to see Lyft for your specific use case, and we help make sure that you can solve your intralogistics challenges. So thank you again and have a great rest of your day.